Good evening, Tito. Hello, good evening. Okay. Okay. So this particular, we've already gone through this particular chapter, data tidying. So this session, we're going to be talking about data tidying. So why do I actually tidy there? So from the name, we know what it means. So it's just simple. It's just to tidy our data and make it ready for analysis. We can't just dive into the data like that. Data can come messy in various ways, like missing values, for example. Now, a typical example is a survey now they are trying to conduct. So when you're trying to conduct a survey now, maybe the people that you actually give to help you conduct the surveys, so those are going to collect the data. Maybe in the process of recording some informations, a person that's supposed to be recorded as 49 is the age is now stored as 499. So that's why examples of things that can go wrong when one is trying to collect data. And also maybe a particular value is not supposed to be in a value in a particular column, or the columns are somehow messy and or the names are not stored directly. So these are things that one needs to handle with when dealing with data. So this is where data tidying comes with. So this session is going to talk about how we can handle such situations and various ways which you can actually use to tidy our data. So one of the primary ways that we can use to tidy our data is called pivoting. It is changing the form of your data without changing any value. So most of the times you want to make a data that has different columns. So for example, now in a data now, you can see a situation whereby instead of storing a column as age, then this column was now stored as the age categories. So we have age 0 to 5, 5 to 10, and so on and so forth for each column. So that means for each particular individual, that particular age will now be stored as here as true or false. So this is just consuming of space and also even in terms of memory wise for the data. So this is why at times we need to tidy data from those range of columns, which can be going from 10 to 20s. We can make it into a single column. So this is one of the way we can use pivoting. So if you are familiar with Excel, you might have already used or have experience with pivoting in Excel. So this is just like squashing of data or expanding of data, depending on the need of that arises for that particular data. So in this chapter, we're still going to be using the tidyverse, tidyart package, which is part of the tidyverse family. So this section now, you can see a tidy data. So it's explained to us that we can actually represent the same underlying data in multiple ways. So it's showing us in various ways in which a particular data can be represented. So if you look at this data now, you can see we have country. This is table 1. We have country, we have year, we have cases, we have population. And we can see table 2. Table 2 has country, we have year, but this time around is type and we have count. So you can see that this is the same data, but it is represented in different formats. In this place, we have cases and we have population. So we have the number of cases, we have the number of population. But in this second table, we have type. Now, under type, we have cases of population. So that means type is of 2. Type carries only 2 categories, either cases or population. So for the cases, we put the value. For the population, we also put the value. Now, from what we just see in these two, data now, you will notice that table 1 we have lower number of rows than table 2. You can see table 1 have just 2 rows. We have Afghanistan for 1999 and we have for 2000. But here we're having 4 rows. We have 2 for 1999, which is handling cases and population, and also 2 for 2000, year 2000, which is also handling cases and population. So you can see these are various ways which you can use to represent this same particular data. Now, if you go to also table 3, you can see now it's also represented another way. You can see this time around it was represented as rate. This is still the same information as here because we know rate is cases divided by population. It's the same thing as rate, which is what they did here. It was still the same thing in this particular data. Most of the times, maybe the person out to work with, you want to work with population, he might not be able to work with this particular data set. So you might need to give him either table 2 or table 1. But in terms of analysis, the best data now among these 3 that one can make use of is that of table 1. Table 1 already has cases in its own column, population in its own column, year in its own column, and country also in its own column. But in table 2, if you want to make use of it for analysis or visualization, you might need to start reshaping it just to make it fit for what you're about to do. And for that of rate, you need to start separating it. If it was given to you like this, you might need to separate this column into cases and population. That is if the person that will even work with the data knows what the numerator and the denominator of this particular column is. So when you are trying to work with this particular data now, the best will just to be to work with table 1. So these are various ways which you can use to represent the data. So now we have 3 rules that makes a data tidy. So first of all is each variable is a column and each column is a variable. So we have each variable is a column and each column is a variable. So you can see one of the reasons why we made number 1. So you can see the one is tidy. They say that each variable is a column. Now this is the variable, which is cases. This is another variable, population. We have year and country. And they say each column is a variable. So it's just like interchanging the 2 of them together. And number 2, each observation is a row and each row is an observation. So each observation inside your column, inside your row must have to be an observation. It can be individuals, it can be countries, it can be students, it can be patients inside it. So it can be records of financial transactions, maybe daily, monthly, or yearly. Each row just have to be an observation. And each value is a cell, and each cell is a single value. So you can see something like this now. We cannot call it a tidy data because currently the rate now is just showing us cases divided by population. But you can see something like this now. Each particular cell, we call a cell is the intersection of a row and a column. So each of these cells now, you can see that it contains a single value. So these 3 conditions makes a data tidy. You can see for the variables and columns, you can see for the observations, you can see for the values. So now we have reasons why do we ensure that our data is tidy. We have already explained. First of all, is just to pick one consistent way of storing data. And second also is to place variables in columns. So to allow R's vectorized nature to shine. So which we have already talked with in previous section. So now we have an example in this place now. So showing how we might work with table 1. So this particular example is showing how we can work with table 1. So let's just copy this. Okay. So go to my arrow and let's paste it. So first of all, we need to have our library, which is tidyverse. We're using tidyr package. So now we can see we already have already loaded our library, our package now, tidyverse. Now second is table 1. So this table 1 is actually together with the package. So it's not as if we need to import it. So we have the mutate. So we're going to create a new column using the mutate. We are going to create the rate column, which is cases divided by population times 1,000. So I'm going to enter, and you can see what I'm having here. You can see my rate now expressed per 1,000. So 1.29 per 1,000, 2.19 per 1,000. This is our rate. So this is how we can work with that particular tidy data. You can see how easy it is. Imagine we're now having that other one that was showing cases and population under a single column called type. You see, it will not be easy to work with it like that. We're going to start converting it into this type of data, which is table 1. Now, also table 1, we can group by year. And if we group by year, we can now summarize total cases for each year. So what is the total cases? We are going to group by year and total cases for each particular year. So this time around now, we're not interested in the countries. Just total cases all over the globe for each year. So if I run this, you can see what we're having now. 250,740 for 1999 and 296,120 for year 2000. Now, if you want to also visualize too, it's also easy. We know that our column, our x-axis is horizontal axis is year, while our y-axis, which is the vertical axis, is cases. And we also have you are going to create a geom line. So we are giving our aesthetics as country and color. We are giving them is we are going to group it by country and also geom points by country. So if we run this particular graph now, you can see what we're having now. So from 1999 to 2000 for Afghanistan, this was how it's not as if there was much change in the number of cases. But you can see there's an increase in cases for Brazil. why for that of China increased, and it's not that obvious, but there seems to be some increase and decrease along the line, as you can view it in this place. Also have scale X continuous. So this is what we just use to breaks. It's just, these are just some customizations I try to plot on the graph. But the main point here is just that it's just, we're just trying to show how easy it is to work with if you have a tidy data. We can't work with those data the way we work with this particular one like this, those other two options. So we have some exercises here. For each of the sample tables, describe what each observation and each column represents. I think we have already talked about this when I was explaining those particular tables earlier on. So describe what each observation and each column represents. So I already talked about it, what each column represents. And now that's it. They say we should sketch out the process you use to calculate the rate for table 2 and table 3. You need to perform 4 operations. So here I've been told what we'll perform in table 2 and table 3. We need to extract the number of TB cases per country per year. We need to extract the matching population per country per year. We need to divide cases by population and multiply by 10,000, and we need to store back in the appropriate place. So now I want to calculate the rate for table 2 and table 3. So let's start with our table 2. So let's go to the R. I think we just save this, and downwards we can start that of table 2. So let's see our table 2. So you can see this is our table 2. This is our count, and this is our type. So now we want to calculate the rate. So how can we calculate the rate? So they've already given us how we are going to do it. So first of all, they say extract the number of TB cases per country per year. So these tuberculosis cases per country per year, and also extract the matching population per country per year, and divide cases by population and multiply by 10,000. So now let's say table 2. So we need to extract the number of cases and population. So we need to divide number of cases by number of population. So let's say we group by country. Let's group by country and see. Okay, group by, sorry. So if we group by country now, we're now going to say summarize rates. We're now going to create a new column called rates. And this particular rate now is going to be equals to cases, or let's say, I think we say type equals to cases divided by, okay, let me see. We want to divide cases by population. Rate is equals to type is equals to cases. Okay, let's try and see if we can extract cases first. Let's try and see if we can extract cases first. Type is equals to cases. Okay. Okay, let's use filter, sorry. Let me just remove this for now. Okay, so now we have this now. Type is equals to cases. And also, let's say we have filter type is equals to, I think, population. So the type is equals to population. So let's see what was the next instruction given. You can do this. So let's say, for example, now, we want to now get our rates. We just say we have 2 tables. I've already extracted these 2 tables now. So first of all, we can just say, call this table 1. We can just call this A. And we can call this B. So this is 2 tables we're having now. see how we can tackle this. Okay, let's say A selects, okay, or let me just do it like this. You can see A type divided by B type. Then we can now see A rate is equals to this. Okay. Okay, sorry. It's supposed to be A count. I think A count divided by B count. So we say A now. So you can see we already have the rates now. So what the process we just did here now is just that we stored the cases as a new data frame and we store the population as a new data frame. Then we now created another new column inside the initial first one, and we can rename the table if we want. So these are already calculated the rates, which is just the same thing as what we have had earlier on. So you can see these are rates. So I think that answers the question. We extracted the number of TB cases per country per year. The same thing for population. We divided cases by population, multiply by 10,000. Okay, sorry, I think we forgot that. I was supposed to multiply by 10,000. So to multiply by 10,000. So still we call A now. So I was supposed to multiply by 10,000. So table 1 too, if we should call table 1 now, I think we should be having the same thing. Okay, table 1 doesn't have the rates. I think this is the one that have the rates. Okay, this is it. So you can see it's the same thing with what we have, what we just calculated now. So this is how we can calculate the rates manually. So we're just going to now start talking about how we can actually calculate the rates without following all those through teachers' procedures. Let's say we have a data that is not tidy. So there are two functions we can use to tidy a data. We have pivot longer and pivot wider. So from the names, pivot longer is used to make the data longer, while pivot wider. So when we say pivot longer, it means we are trying to increase the number of rows inside a data set. When we say pivot wider, it means we are trying to increase the number of columns inside a data set. So from the names, you can even understand what the function does. So this is an example now. We have the Billboard data set. So the Billboard data set now, you can see this, we have 71. We have, okay, I think we have 79 columns and we have 317 rows. So in this data set now, each observation is a song. And the first 3 columns, artist, track, and date entered. You see, we have it. Are variables that describe the song. Then we have 76 other columns, which are week 1 to week 76, that describe the rank of each song in each week. Now, here the column names are one variable, the week, and the cell values are another, the rank. So to tidy this data, we are going to make use of what we call pivot longer. Because now we are trying to make this data set from having high number of columns to having low number of columns but high number of rows. So which means from 79 columns, we want to make this data to now have 4 columns. We are making sure that all those columns that are inside this data set now become rows. And all the we are making sure that all the columns inside this data set are values inside a single column and a single variable called week. So this is how we can use pivot longer. So let's copy this code now. We go to R, we paste it. So we can see our Billboard. These are Billboard data sets, which is also part of the package, and we have pivot longer. So these are the arguments that pivot longer actually takes. First of all, these columns. So which columns do you want to convert to values under a single variable? That means which columns are you interested in? So now we are telling pivot longer that we're actually interested in columns that start with WK, because it is all the weeks that we want to convert as values under a single column called week. So any column that starts with WK, we want it to be a value under a column called week. Then the next is names too. Now, the new column that I'm trying to create, the single column that is going to accommodate all the values here. What do you want the name to be, which is week? then what do you want the values to be? Because don't forget that these weeks now, if we look at the Billboard, this is the Billboard data set now. These weeks have values under it. We are not going to discard these values. So what do you do with the values under each week? Then for each respective week column that we converted to a value, we are going to create another column called rank, and we put that particular value inside that particular column. So when you run this now, this is what you now have. You can see that what each column there, which is week 1 up to week 79, I think up to week 79 also, has its respective rank, which is 87. So if you see another week here that is having missing value, maybe it's possible that particular week doesn't have a value. It's possible. So now, this is now what? If you check the dimension of this, you can see it is what? The number of rows have increased from 317 to 24,992. And you can see the number of columns have decreased from 79 to 5 columns. So this is how pivot longer works. And now the next one that we have, still also on the pivot longer, is just explanation of the arguments. Okay, now we have something about the NA. So they're talking about the NA. So let's turn our attention to the resulting longer data frame. What happens if a song is in the top 100 for less than 76 weeks? So for example, now, a song now will be in the top 100 for just 7 weeks, which means that all other weeks is going to be carrying missing values, something I talked about earlier on now, and all the remaining weeks are filled in with missing values. So these NAs don't really represent unknown observation. They were forced to exist because of the structure of the data sets. So we can ask pivot longer to get rid of them by setting values drop NA is equals to true. So what this is trying to explain is that if, for example, now a song now was in the Billboard for less than 76 weeks, so the other weeks are not going to be occupied. So this doesn't mean that it's actually a missing value. What this actually means is that for that particular song now, the rating wasn't available for all those other weeks. So this is where we're not going to use these additional arguments called values drop NA is true. So if I come this and add this, and put my comma, enter, you can see that the number of rows has decreased because we have already removed all these ones with NA. These ones indicated that this song didn't have a rating for that particular week, not that the value was missing. There was no rating available for that particular week. That was why we are dropping these particular rows. So from 24,000, we are now left with what? 5,307 rows. So which means that your data cleaning doesn't end in this place. You need to also take care of your missing values. So now this is saying we could make future computation a bit easier by converting values of week to character strings or to numbers using mutate and using this particular read r pass number. So pass number is a handy function that extracts the first number from a string, ignoring all other text. So what I'm just trying to do now in this situation is that instead of just having week 1, week 2, we just want to make it to be numbers. So we're not going to use mutate. So mutate creates a new column for us or changes that particular column we have. So if you are using mutate to rename, if you are inside your mutate function, if you are still creating a column with the same name of the column you are trying to change or you are trying to manipulate, so you're going to replace that particular column. So if I should run this now and call Billboard longer, you can see now that our week is normal with WK1, WK2. It is now the digits inside that particular string, 1, 2, 3, and so on and so forth, as you can see in this place. So now the next now that we have all the week numbers in one variable and all the rank values in another, so we can now visualize how songs rank over time. So we can just come here to visualize how songs rank over time. So this is our graph. So this is how songs rank over time. So the rank of songs and over the weeks. So you can see that in the first 20 weeks, a song will actually be a hit. So the song will actually trend. But as time goes on, you see that these particular songs that have been trending for the past 20 weeks are not going to be trending further for more weeks to go. So this is how we can use pivot longer. So how does pivoting works now? This is just trying to simplify how pivoting works. So just trying to simplify it a little bit. So already this is just a sample data frame, as you can see. We have 3 columns here, ID, BP1, and BP2. Now we're using pivot longer now. This BP1 now, using pivot longer now. We want to make sure that BP1 and BP2 are under a single column, while all these values are also under a single column. So that means from that, if BP1 and BP2 are going to be under a single column, that means we are going to have, let's say under that single column now, I'm going to call it measurements. So we're going to have A BP1 and also have A BP2. Then we have B BP1, then we have B BP2. We have C BP1, we have C BP2. So initially we're having 3 rows, but because we have used pivot longer to convert BP1 and BP2 under the same column called measurements, then we are going to be having what? 6 rows instead of 3. And all these values now, we now shift them to value. So each ID with its BP1 is now going to be having its respective value. So this is a summary of how pivot longer actually works. You can see a diagrammatical representation here. You can see that from 3 rows, we now have 6 columns and 6 rows, I mean. And BP1, BP2 now fall under measurement, while all these values now fall under value. So this is how this particular pivot longer works. Even from this, you can even understand how pivot wider also works. You can just have an idea of how it works. It is just the opposite, from column to rows, from rows to columns. So this is just the example. You can see for it now, A BP1 is 100. You can see A BP1 is 100. So you can see A BP2 is 120, A BP2 is 120. So when you are using pivot longer, from a data set that have a high number of columns, by using pivot longer, you should be expecting a data set that have higher number of rows but lower number of columns. So that's what I'm going to be expecting. Even though in this our example now, the number of columns is still the same, where because you can see we still have 3 columns here, 3 columns here. But if you look at the billboard we did earlier on, you can actually see how the pivot longer actually works. So now they say a more challenging situation occurs when you have multiple pieces of information crammed into the column names. So you have multiple pieces of information inside your column names, and you would like to store this in separate new variables. For example, now look at this WHO2 data set. Now, the source of table 1 and friends that you saw above. So this one, or this data set we're looking at now, has 7,240 rows with 58 columns. So now what we're trying to do in this data set now is that there are 2 columns that already have variables and are easy to interpret. We already have country and year, but all these ones are not variables. So they are followed by 56 columns, which you can see as we have here. Now, if we stare at these columns for long enough, you notice that there is a pattern. Each column name is made up of 3 pieces separated by this particular underscore. So each of these column names is made up of, is separated by an underscore. So the first piece is SP, rel, and EP, describes the method used for the diagnosis. While the second piece is male and female, is the gender, coded as a binary table in this data set. And the third piece, which is the number, is the age range. So each column now, you can see this is a very dirty data set now. Each column now is containing 3 variables. First of all, we have the method used for diagnosis, then we have the gender, then we now have the age range. So how do we undo this particular piece of information now? So now for us to undo this particular information now, we are going to use pivot longer. Then our columns, we are going to exclude. Now, if you look at it now, instead of selecting all those columns because they are much now, and there's no way we will actually make it, because unlike the billboard, we see it start with week. So we just excluded country and year. That's what we just did now. So which means now we want to make these columns into variables, but exclude country and year. Now, the new columns we're trying to create now, we are not creating a single column now. We are creating 3 columns: diagnosis, gender, and age. But if you look at these column names now, they are separated by an hyphen. And any value you have there, convert it into any value you have inside this place. Convert it into a count. So let's copy this and go to R. So now let's run this now. Or first of all, let's run our WHO data set, which is WHO2. So you can see it now. 7,240 rows, 58 columns. And each of these columns is actually 3 columns. And so what we just want to do now, we want to create 3 columns on their own and carry the respective values and assign it to each of the respective columns. So I'm going to run this now. And now you can see that from 7,240 rows, we now have 405,440 rows and just only 6 columns. We have country, year, diagnosis, gender, and age. So for the age, actually, I think it's the age grouping, the age range. So just 0 to 14, you can see it here, 0 to 14, 15 to 24, 25 to 34, and so on and so forth. Okay, now you can see the table showing what happened just now. You can see we have ID X1 and we have ID Y2. So X is a column on its own, one, or let's say X is a variable on its own, 1 is a variable on its own. Y is a variable on its own, 2 is a variable. So X and Y are under, I'm going to put X and Y under the same column, Y1 and 2 is under the same column, but the hyphen is separating them. So which means we have our ID here, we have our name. So X and Y are going to fall under name. And we have number. So X1 will now be 1, which is this. And we have Y2 is going to be 2, which is this Y2. You can see this is this. So I already make this cleaner now. So with this now, we can analyze name separately and also analyze number 2 separately. Another complexity we can have is when the column names include a mix of variable values and variable names. Now look at this now. We have a mix of variable values and a mix of variable names. So we can see we have family. We have, okay, I'm still trying to understand. Okay, we have date of, okay, we have family. We have date of birth of a child. We have date of birth of child 2. We have name of child 1. We have name of child 2. Now, what we just happen here now is that we have already mixed what? Variable values and variable names together. So date of birth of child 1, date of birth of child 2. So now, for us to clean this data set now, we have to select the columns we're interested in converting into a longer, the column we want to convert into values in a column. So we're going to be excluding family, which is this. And next, names 2. The new columns we're now creating are what? Value and child. Dot value and child. Now, we're going to be separating, names are separated. So how are these particular names separated? They are separated using an underscore in the initial column names. Then we now want to drop missing value. So let's copy this now. And paste this. So you can see if we run this now, you can see initially this was our data set household. So this was our data set earlier on, which is what? 5 rows and 5 columns with 3 columns, 5 rows and 5 columns. So you can see we have date of birth of child 1, date of birth of child 2. That is under each household, though. These are the various childs that we have. But we want to now convert it in such a way that we want to have the details of each child for each household. So each, just like a tidy data is, each observation should be each row should be a single observation. But if you look at this place now, each row is not a, if you look at this, I think this is the initial one. Each row is not a single each row is not a single observation because you're having child 1, you're having child 2. We want to make it such a way that each row is a single observation. So this is where we'll clean it like this also using pivot longer. names too. Names are separated by underscore, and we drop the missing value. So from that, we now have 9 rows and 4 columns, which you can see on the console. So you can see a colored explanation here: X1, X2, Y1, Y2. So it's different from that other one. X1 and X2, you can see this, they're both under the same variable X. Y1 and Y2, 1 and 2 are also both under the same variable Y. Now, in this situation, each of the row is not representing an observation. So we need to make it like in such a way that X is on its own, Y is on its own, and we also have number 2 also on its own. So we have X, 1, and 3. We have number, which is what? 1. We have also under X, we have 2. That is X 2. We have number, which is also 2. If you look at this now, X1 is 1. So X1 here, the number under it is 1. X2 also, look at it, X2, the number under it is 2. And so on and so forth. So now the next is widening of data. How do you actually widen data? So I think my PC is about to die, so I don't know if Ms. Bilkis can continue with the widening of data.
Okay, maybe I'll take
just
that.
Handle the widening of
Let
data.
me just
so
switch.
About, yes.
Okay.
So I think I'll be going now.
Okay, like my colleague has rightly mentioned, widening data helps us to increase in number of columns. So now if we're increasing the number of columns, we are reducing the number of rows. And this helps when one observation is spread across multiple rows. Okay, so this seems to, from the explanation here, we'll just go straight to the example that we have. We'll start by looking at this data set. So CMS patient experience. So it's a data set from the Centers of Medicare and Medicaid Services that collects data about patients' experience. So I'm going to copy this code and go to my RStudio. So we're in RStudio now. So I copy this down. So I'll just take this. So if we look at my console, we'll be able to see the data. So we have columns, 5 columns here. It's a little bit small. So, but we have some columns that actually have multiple values in it. So let's go back to our book. So what do we need to do? So the core unit being studied is an organization, but each organization is spread across 6 rows, okay? So with 1 row for each measurement taken in the survey organization. So we can see the complete data set, okay? Values, so the set of values for this and this by using distinct. So let's copy this. We want to look at the actual values that are not repeated by using the function distinct. So I'll copy this, get back to RStudio. So we'll drop in that there. So let's run this and look into our console. So we have 6 distinct measure title. So for the first one, how many rows do we have there? We have 500 rows. So, but for the 500 rows, we have distinct measurements that belongs to these columns are just 6. So we have measure CD that is just 6, and also the measure title at just 6. So let's get back to the R for the science book. So what we can see here is that, okay, neither of these columns will have particular grade So sorry, I have to read through the book. I was looking forward to my colleague taking the class. So, so it's long. So we'll use the measure CD as the source for our new column names for now. So, but in real analysis, you might want to create your own variable names that are both short and meaningful. So we're going to use the function pivot wider, which has the opposite as the pivot longer, like my colleague already discussed with you. So instead of choosing new columns, we need to provide the existing columns that define the value from, that's for this argument. Then the column names here is going to be for names from. So we're going to derive, the values are going to be from whichever columns that we stated here for this argument, and the new column names are going to be derived from these ones, okay? So, like it's rightly said in the documentation, it might not be meaningful, but that is the only way we can get something meaningful out of the data that has been collected. So we'll go ahead again to collect the code that we have here. I'll go into RStudio, then I'll explain each line to you. So here, what we're doing now for this function, pivot wider, you might want to, something I will always encourage anybody to do is to look at the documentation. So the documentation is not far-fetched. You just have to use the question mark pivot wider so that you know where all these arguments are coming from. So if I go to my documentation now, you will be able to see there's a lot of argument that could be passed to this function, but just a few, that's just two of them are going to be what we're looking at today. So the argument here now is for names from. So from the documentation, all we have is a pair of arguments that for these two arguments, names from and value from, like Israeli said, a pair of arguments describing which column or columns get the name of the output column, that's this, and which column or columns to get cell values from. Okay, so now what we're passing here is the distinct values that are coming from this column, measure underscore CD. That's where the names are going to be coming out. So you look at my console, measure underscore CD. These are the values there. So, so that's going to be what we're going to use for what? The column names. So values now are going to come from PRFT. Let's check the data again. I'm not familiar with this data. So that's the last one, the last column from this data set. That's the last column here, okay? So let's run that and see what we'll get. So from the output of this code, we can see that let me just expand this. We have 4 extra, I think that would be 4. No, yeah, 4 extra columns that have been created for us. So this is, the first one is this, that is CH, well, you can see the values here. So I don't want to go through repeating that again. So that is the first value here. That's first column, second column, third, and now we have all these columns, all these values now have been used to generate new columns. So that's what you will see here, 1, 2, 3, and then 5, the 5th one. So from what I can see here is that we have some columns that are not displayed, which are shown down here. So if I want to see everything here, let's use the function view. Then we'll pass, we might want to pass this, let me just do it here so that you'll see all those columns that are created using the values that we had in the in the columns measure underscore CD. So I'm going to take all this and push them into this function view. So we'll be able to see that. So just imagine that, okay, the output of what we had from line 9 to this is what we're going to see in an Excel sheet format. So a table format that is kind of something that we can relate to. So those 6 distinct values are now represented here. That's 1, 2, 3, 5, 8, and this. So they are all 6. 1, 2, 3, 4, 5, 6. Okay, so that's from that distinct. Then you can see that, okay, that is what we've used to generate our new columns. So if you also notice, we have some missing values here. So let's go back to the book and see how we can resolve that. So going back to the book now. So if we look at that, we're going to see that, okay, the values that we needed has been generated. So let me see if we're going to move on with that. So the output doesn't look quite right. So yes, so we still seem to have multiple rows for each organization. That's because we also need to tell pivot wider which column or columns have values that uniquely identify each row. So in this case, those are the variables starting with org. So now the variables now are these ones. What you can see from the screen I'm sharing here, we have some columns that are starting with the org underscore here. So let's see how we can use that to help refine our data. So I'm going to copy this code now. I'm going back to my RStudio. Sorry. I need to bring this up again. So I'm going to dump this again here. So the code here is actually telling us from the explanation is that we're going to get a better understanding of the data for us to be able to make it a little bit wider from this column. Although the names of the extra columns that we're adding are coming from names, this argument names underscore from, and the values are coming from the column PRF underscore rate. So this is an additional argument that is helping us to refine our data. So let's see what the output is like. So now if you look at what we had before, was still 500 rows. Okay, so now with the help of the ID underscore calls argument, we've been able to reduce it to what? 95 rows. So then we have 8 columns now because the columns that we had before have been taken out. So this column measure title has actually been placed somewhere. So let's just use this. Let me use this function again. I can't get a good appreciation of the output there. So if we look at this, we have now 8 total columns. Okay, we still have the columns that were generated for us, but right now we are short of this column, the other one that we had, the title, that measure underscore title. So that has been actually remodified where we have left for us now 1, 2, these columns, plus the extra 6 that was generated. So that is the way we can actually get more meaning from our data by making it wider. So let's go back to our book. So this gives us the output that we're looking for. So how does pivot wider underscore wider work? So to understand pivot wider, let's again start with this very simple data set. So we're looking at another data set. So this time we have two patients with IDs A and B. So this is what we have here. So we have 3 blood pressure measurements. So on patient A and 2 on patient B. So this is what we have. So we're going to generate that new table using this function dribble. Okay, so let's copy this. So before we go back to our studio, let's just look at what we're having. So we take the values from the value column and the names from the measurements column. So this is going to make it a little bit wider because right now we have 3 distinct values under the measurement column. So let's go to our studio. So I'm going to continue here. So first of all, let's create our table using the table function. Then we'll go back to the book and we'll copy this out. So from what we can see here, we're using the pivots wider to make our data frame or table a little bit wider with more columns. So what we're doing is that we're using the values inside of 2 columns. That is the measurement as well as the value column to make it wider by passing the first one, that's the measurement column or variable, to names from, that's an argument. Then values are going to be taken from the value column. So for any of these columns that are newly created, they're going to get the equivalent of the values from the value column. So let's run this. So, okay, let me clean up and bring back the code. So now, instead of having, how many columns did we have before? So we have 5 columns. Now we're having only 2 columns with extra. No, we are short of 1 column now because before what we had was 3 columns. We've used 2 columns to make it a little bit wider. So now the 2 columns are gone. We now have it replaced with 3 new columns. That's the BP1, BP2, and the BP3, because those are the unique values that comes from the measurements column. And the values, the corresponding values are also from the values column. So if patient A did the first BP, that's BP1, so the value is going to be 100. And you can see from the column that we have, for patient A, when we took the first BP, it was 100. That's just what we had here. For the second BP that we took, it was 120. And if you look at the data, the original data set is also 120. Then for the third BP we had for patient A, it was 105. So, but for patient B, we only took 2 BP, blood pressures, that's for BP1 and BP2. So that's why for BP3 is now NA. So it's a missing value because we didn't take any measurement for the third time for patient B. So let's take a look back at okay, where is my the values that will go into the rows are coming from the values column, while the values that are going to be for the column names are coming from get by assigning the measurement column to names from. So while the values are going to come from where? They are going to come from the values column. So by default, the rows in the output are determined by all the variables that aren't going into the new names or values argument. So that is, we're referring to the ID column. So the ID column actually had only two distinct values, A and B. So that means invariably we're going to get what? Two rows. And that's exactly what we had. So so that is this for the pivot wider. So let's look at this. So pivot wider then combines these results to generate an empty data frame. So sorry, I hope I've not jumped something. Okay, actually, yeah. So it's a bit more of an explanation here. So pivot wider then combines these results from the first one that we did to get out these distinct values, and the second one where we get values that are going to determine the number of rows. So combining these two together, we get something like this. So it then fills in all the missing values using the data in the input. So in this case, not every cell, just like we had, not every cell is going to have data. So just an example would be that for the B, the patient B didn't do the third measurement for the BP. So, and that is that. So I believe we're going to stop here. So if this is actually referring us to, if we attempt to pivot this, we get an output that contains list columns, which you will learn in chapter 23. So we would want to stop here. We don't want to jump to chapter 23 for those who are just beginning with R. So just know that there are some basic arguments like the names from and the values from that you can use to determine the width or how wide your data frame is going to become. And the number of rows is now going to be determined by the other columns that are not involved in this widening of the data set. So, and that is just a summary of what we have here. So we wouldn't go into it. So let me give a summary of everything that we've learned in this chapter. So in this chapter, you learned about tidying data. So data that has, so when we're talking about tidy data, we're talking about data that has variables in columns and observations in rows. So tidy data makes working with tidyverse easier. So because it's consistent structure understood by this talk. So to that end, you learned about pivot longer that was taken by my colleague Ridwan, and also pivot wider that I just went through now. Okay, so which also helps us in tidying up our data. Okay, so you can check more about these two functions using this statement here, or you check the documentation in your R Studio by just using the question mark. Let me take you back there. So if you go to maybe within your script or just use the question mark, you can say, just get the information. Pivot longer, you get it in your help tab, okay, here. Or you just go to click on the tab, go into the search box here, then you pick pivot wider. Let's use that now. So you get information and you have tons of so many arguments that you can use to tidy up your data using these functions. The same thing, you go back, you see so many arguments here that you can use with the pivots and longer and the pivot wider functions. So that is that. So information is always at your fingertips. Just get it and you'll be able to learn more about this. So another challenge is this. So I think we'll round up here on this chapter. So sorry for the cut off. My colleague had a power issue. Is Nigeria here. So well, we're grateful. We're good with all the resources that we're having. So please don't worry. Next session, we're going to go more into details and then we'll be able to catch up on some of the other columns. So thank you so much. And we'll see you in the next session next week. Where we're going to be looking at the geocomputation and also R for epidemiology. So the two study groups are going to be featuring next week, and we'll hope to share more details about it before the sessions. So thank you and goodbye.